Okay, brother. So today we will do problem 1 using the software SWP, okay, scientific workplace. Okay, but first for this we must know that what are the requirements of the problem, okay, because SWP is not an automated thing. Okay, you have to do what you have to be achieve. Okay, if you need to do something, you should know the process of it actually. Okay, it is the job of the software to find it, but at least you should define it, that what to do next. Okay, so that is why I am starting my lecture from the page, and then I will move towards the computer software. Okay, so the first thing is that this problem, first problem, actually it will be a problem with a single variable. Okay, it will be a single variable problem without constraint. Okay, we know that when we have without constraint problems, they are either quadratic or non-quadratic form. Okay, we will try to do both of it using SWP, but the first thing that we should do is to define the process of it. Okay, so if we have one variable, okay, and it is a quadratic function, for example, in this lecture we will do the problem that is 3x square plus 4x. Okay, f of x is equal to 3x square plus 4x. Okay, now the variable is equal to x. Okay, and here we have square and here we have 1, so it is actually non-quadratic form. Okay, it is non-quadratic form, and here it is only one variable, and we know that the Hessian matrix, it is n cross n, so 1 cross 1 is 1. So if the second derivative of it is less than 0, okay, it is minima, and if f double prime of x is greater than 0, it is maxima. Okay, so this is the very first thing that we should know, and we will implement all these things into the SWP. Now moving forward to the software part. Okay, so now we have the software part of it. Okay, and we have a new latex file. Okay, now the first thing that we need to do is to define the function and variables. So to define function, okay, it can be done from using compute and then using the definitions and new definition. Okay, now this is the new definition, so I will write, okay, we need to do it, isn't it? Is already in maths, but okay, now I will write f of x is equal to, okay, I will write 3x square 3x, and to write the square I will say control H, so it will go to the power of it. Okay, I will say square, I will write 2, and then we'll press the space bar. Okay, space bar will bring it to the main syntax. Okay, now when we press the space bar, I can now make another entry. Okay, I will say plus 4x. Okay, and I will press enter. Now we have defined the function over here. Okay, now we know that we need to find the first order derivative with respect to x to find the value of x. Okay, to find the value of x, we must first define the first order derivative. To define the first order derivative, we go to, because it is d by dx, okay, so we will go to this option, this fraction. Okay, click on it. Now we have a fraction part. Okay, now in the upper one I will this is the partial derivative sign. I will put this over here, okay, and I will say f of x, okay, and with respect to, I will come to the denominator and I will say the partial derivative, and I will say with respect to x. So partial derivative of fx with respect to x, that is what we need to do. Okay, I am trying to do a bit of focus on it. Okay, now to solve it, actually we can also define it into the in the enclosed shape, but that's not actually important. The important thing is to solve it. Okay, we select it and we go to compute and we evaluate it. Okay, but it says that it is f, it means that we have not properly defined the function. Okay, so we will go to backspace. Okay, we will first define this thing again. To make it, I will define compute definitions and define. Now I have defined the f of x. Okay, now let's see if it solves it. Go to compute and evaluate. Now it have solved it. Okay, so you will come up, there will be problems in it, like just like I came with the with a problem. Okay, so you will have problems in it, but you will define it properly to avoid any problems. Okay, you can also check it in compute and definitions to show the definitions. Okay, so it will show you all the definitions. So if something is missing in there, it will show up in here. Okay, if that is missing in this part of the problem, okay, it means that you have not defined that thing. Okay, so you can actually know about the what you have defined and what are undefined till now. Okay, so if something is missing in there, you should go back to the problem, close it, go back to the problem and define the function again. Okay, so that is how you verify that you have defined a problem, a variable, a function or not. Okay, I will press enter and now I will define it another thing. Okay, to define I will say control plus E, so it will define it. Okay, now I want that we know that we have to put the derivative, partial derivative of the function equal to 0. So I will select this thing, I will say control C, okay, and I will put it over here, control V, okay, and I say that it is equal to 0. We can also make control D, sorry, okay, let me define it again. Okay, to make new definition I say control plus E is equal to, sorry, okay, now 6x plus 4 I control C it, what let's do this thing again. I evaluate it, then I copy it. Actually I am on one hand I am using mobile, on the other hand, so I have to, you have to copy with me. I say control V over here and I say that it is equal to 0. Now we have a equation over here to solve for x. Okay, so I go to compute and I evaluate it. Okay, but this is to be evaluated numerically or solve it. Okay, so I will go to compute and solve, and I want an exact solution for it, so I solve it exact. So solution is minus 2 by 3. It means that x is equal to minus 2 by 3. Okay. Also another thing, we can do another thing. Okay, we can actually write the equation in the next one. Actually, oh man, I can write the equation in the next part. Let's control C it and control V it over here and put it equal to 0. Okay, now I have the equation over here. I want to solve it for x, so I can go to compute, solve, and I want a numeric answer for it. So the solution is x is equal to minus 0.66667. Okay, so that is how you solve it for exact value in decimals. Okay, now this is the solution that we wanted. Okay, but we don't know if this point x is equal to minus 0.667, this is maxima or minima. Okay, so we find the double derivative of it. Okay, so we press enter, and now we want the double derivative of the function of x. To find the double derivative of function of x, we click on this fraction. Okay, when we get this fraction, I say this, and I want a square of it. Okay, so I would say that control H. Okay, it will go to the power. Okay, I want square of it, and I will press space bar, and I will write, or I can copy this f of x from here. Okay, to be exact, we want to put the exact thing that we have defined, so I will copy it from here, so I will not be there, it cannot go wrong. Then I will say control V, and here I put the dx square. Okay, so partial derivative, I got it, then I got the x of it because it is with respect to x, and now I want square of it, so I will say control H and 2. Okay, now I want to compute, so I want evaluate it. Now it is equal to 6. Okay, now we know that if it is positive, we have the condition over here that when the second derivative is positive, it means that it is maxima for it. Okay, and when it is negative, it is minima for it. So this point is maxima for it, so hence prove that it is maxima. Okay, that is how you solve the problems, simple problems. I will move to the next, like a quite the problem which have like 2 variables with no constraint, then 3 variables with no constraint, and then I will go to the constraint problem. I will first go to the Lagrange's problem with equality constraint, with 1 constraint, 2 constraint, 3 constraint, and so on. Okay, and then we can solve some more complex problems with it. Okay, thank you. This is for the simple problem. Okay, in the next video I will continue with the a bit of complex problem. We have 2 variables x1 and x2 without any constraint, then we will have like 3 variables. Okay, and we will know how to deal with the the problem with so many variables. Thank you. Okay, now we will move to the problem with 2 variables. Okay, now this is problem 2. Okay, and we are solving using SWP software. Okay, and it is a problem with 2 variables x1 and x2. Okay, so the function f of x1 x2 is equal to x1 square plus 5x2 square minus 10x1. Okay, this is the function over here. Okay, now you should know the basics of it. If you don't know the basics of it, you cannot solve it using the software, because software will not do you anything to you automatically. You need to tag it, you need to make the input, the exact input that you want output for, and then it will calculate only, it will only make the calculations. Okay, you should define each and everything at each step, and then it will make the calculations. Okay, it is not some automated process. Okay, so we have the function now. Okay, we have like two variables over here, okay, x1 and x2, and we, as this is the non-quadratic one, because it is has this term, the third term has only one power over here, or 1 degree over here, it is 2 degree, it is 2 degree, so it is not quadratic form. So when we have non-quadratic form, we actually make the Hessian matrix for it. Okay, and Hessian matrix is equal to, it is n cross n, so it will be a 2 cross 2 matrix. Okay, and the first one here, we will have the derivative of this function, the second order derivative of this function with respect to x1. Okay, and here it will have the second order derivative with respect to, this is x1, this is x2, this is x1, this is x2. I am simplifying it for you. Okay, okay, so the first order derivative will be with respect to x2, and the second order derivative will be with respect to x1. Okay, and here it will have the first order derivative, it will be with respect to x1, and the second order derivative will be x2, and here the first order and the second order both will be with respect to x2. Okay, so now we also need to find the Hessian matrix. Okay, and if the determinant of h of x is this determinant is actually if you find the determinant actually, okay, and if it is greater than 0, and the first element, this one, depends if a1 1 or d1, the first minor, it is less than 0 and d2 is greater than 0, it means that it has a alternative signs. Okay, then this is local maxima, because it is negative definite then. Okay, so in the question we will actually look for the conditions also. We will find the principal minors, okay, depending on the matrix. Okay, it is 2 cross 2, so we will have only two minors, the first one and the whole determinant of 2 cross 2. Okay, so let's go to the problem and let's see what we can achieve over there. Okay, so here we have the new you can say the new input worksheet actually. Okay, now we must define the function first. Okay, to define the functions, okay, we press control plus the equal to sign. Okay, control plus equal to. So now we are in the definition mode. So define, and first make it the mathematics. This is t. Okay, when I press it, it will go to the mathematics form, and then I press control is equal to, and it will go into the definition modes. Now I am defining the problem. So I define f of x1 comma x2, but I must make the x1 and x2 in the subscript. Okay, so to make into the subscript, it says control L. Okay, so it will go to the subscript. Okay, so I make it is x2, and for 1 also I say control L, and it will go to the subscript. So I press 1 and press space over here too, so it will come to the original position. Okay, and I make the bracket close, and I say it is equal to, okay, x1 square. So for 1 I say control L 1. The one other thing that you can do is, okay, you don't need to actually write it, just copy the x1 x2 from here, actually make control C and control V over here. Okay, now you have both the scripts written. Okay, and I say that x1 plus x2, okay, I have like x1 square plus x2 square, so I will make the control H, okay, and I say that it is square. I press the space key and it comes to the next term. Okay, now I have 5x2 square, so I will write 5 over here, and after x2, okay, when it is in the main syntax, okay, I press control H and it come to the power of it. Okay, and I say that this is square, and I press the space bar and it goes to the normal writing. Okay, and I say minus 10 x1. Okay, so for 1 I must write control L and then write 1 and press the space bar. So now we have defined the function. Okay, this is the function that we are interested in, and find the maxima or minima for it. Okay, now I press enter. Okay, now when I press enter, I want to know that if the function is all defined or not. Okay, so I go to compute, then I go to definitions and I say show definitions. Okay, it means that it is not defined yet, it is blank over here. So I close it. Okay, select the whole function. Okay, compute, go to definitions and I say new definition. So now this is defined. Now when I go to compute and definitions and I say show me the definitions, it is showing me now the exact definition of the function with all the variables. Now the function is defined. Okay, you must verify it using this method. Okay, because sometimes you don't know if it is defined. You keep in mind that it is defined but it is not defined, and it doesn't make any calculations. Okay, but the main problem is like you haven't defined or mapped it. Okay, and you see for other problems like what is the problem, but the main problem is that you have not defined it even. Okay, so you look for the definitions of it. Okay, now that the function is defined, the next thing that we do is to find the stationary points. Okay, so I write find stationary points. What the hell, man? Okay, and I say press enter. Now this is in black actually. Okay, so this is normal text. The computer, the inside programming, actually it will not take it as an input. Okay, it is just for you. Okay, now to find the stationary points, what we do is we find the derivative of the function with respect to x1 and x2 respectively and make it equality to 0, and then solve the simultaneous equations to find x1 and x2. So we will do exactly the same thing over here. Okay, now I say that I have d by dx, it is in a fraction form, so I put the fraction over here. Okay, now the partial derivative sign is this one. Okay, so I put this one and I actually copy this f of x1 x2, control C, and I make the control V over here. Now I have actually copied it. Okay, and it is defined in the upper section, so it will do exactly what I want him to do. Okay, now in the denominator I have the partial and with respect to x1. Okay, Now x1 is already written over here, so I must copy it, Control C, and I put it over here. Okay, now I need to find this thing. Okay, but not only this thing, I also need to find with respect to x2. Okay, so I make the Control C and Control V over here, and this x2 I will erase the x2, the only two part, and I will say the one part, and I will say that do it with respect to x2. I just write x2 over here. So this is now a kind of simplified for me. I have this thing actually, so I don't have to write all the the term. I just make this change. I change 1 to 2, and let's define it into the in the bracket, enclosed thing. Okay, it is done with the Control D. Okay, now I will find this thing. Okay, I will compute and evaluate it. When I evaluate it, it comes 2x1 minus 10. Similarly, I will select this and go to compute and evaluate. Okay, I can also directly do it with respect to not using the compute this option, but directly Control E and it will evaluate it. Okay, let's suppose we delete it. Okay, okay, so now I have deleted all the other things, and I say that Control E, it will be done singularly, not the, you see, it is directly done. I am not going towards the compute and all the option. I just press Control plus E and it directly evaluates it. Okay, now I need both of these equations actually and make it equated to 0 to find the value of x1 and x2, which is the stationary points. Okay, now I just copy this thing, okay, and equate it to 0, and I can say that I press Control D and it will come into this shape. Okay, now I press enter and it copies actually. Okay, now I say 10x2, I make Control C and put it in this, and I press equal to 0. Okay, okay, now these are two simultaneous equations. Okay, so when I press enter, I say that solve equations for x1 and x2 and press x2 okay. Now I want to solve the simultaneous equation, so I click on this and I go to compute and I solve, and I say that solve for the exact values of x1 and x2. Okay, so the solution is x1 is equal to 5 and x2 is equal to, let me do it again actually. Okay, now I click on this, I say compute and solve it for the exact values. So it gets me the exact values for x1 and x2. Now the solution is x1 is equal to 5 and x2 is equal to 0. Now we want to find if these values are maxima or minima. So for that we need to make a Hessian matrix. Okay, so I would say making or make or compute Hessian matrix and press enter. This is for me only. Okay, this is not for the software. Software will not read it actually. Software will read only the mathematical part, which is in the red one. Okay, to make the Hessian matrix we must define a matrix first. Okay, now this is the sign for the matrix. Okay, this is the sign for the matrix. Okay, now I click on it. When I click on it, it says what is the order of the matrix. Okay, so this, it has two variables, so it will be 2 cross 2. Okay, 2 cross 2, and I say okay. Okay, now it's, let me explain that what is the values for these four variables in the Hessian matrix. So the first one is actually the second order differential with respect to x1. Okay, so we must make the second order differential of f of x with respect to x1. So let me define it over here. So I would say the fractional part. Okay, and I will say the partial fraction. I would say control H, and I may say that it is square, and I press space bar. Okay, now I must say that this is for the f of x1 x2. Okay, so I press control C and make it with respect to x1 square. Okay, so this is x1. I copy it from here, control C, control V, and when it copies, I say control H, and it will go to the power of it. So I make the sign of 2. Okay, now this one is defined. Okay, now I also need it into the diagonal other one. Okay, because in the other diagonal we also do it with respect to x2 square. Okay, so I make the control C, put it over here, control V, and this x1 actually I make it x2. The only change that I make over here is, okay, this one is for x1 square and this is for x2 square. Okay, that is why I copied it. Okay, so I don't have to write the f of x1 x2 and all that. Okay, now in this one the first order derivative is with respect to x2 and the second order derivative is with respect to x1. Here the first order with respect to x1 and the second order is with respect to x2. So I will now write it over here. Okay, now we already have this thing over here, so I will copy it, control C, and I will control V, and I say differential of x2. I will say control C and control V. Okay, now control C and control V over here. Now this is x2. Here the first one is with respect to x1, so I will erase the x2 and write x1 over here, and for this I will erase the 1 and make it 2. Okay, now we have all the things defined in this matrix. Okay, now I will compute it. Okay, I will say compute matrix, and I will say the vector calculus, and I will say the Hessian. Okay, there must be another procedure also for the Hessian matrix, but I will evaluate it actually. Okay, now I will evaluate it actually. Control E. Okay, and it comes that the Hessian matrix is equal to 2 0 0 10. Okay, now that it is calculated, okay, we want to know the principal minors. So I will write principal minors. Okay, or we can say that the minor test. Okay, matrix minor test, or we can say that defining the principal minors. Definition. I will press enter, and with that I want to, you know, define the determinant of 2, this one, and the determinant of 2 by 2 matrix. Okay, and find the signs of it. Okay, okay, I now I need to know the definiteness of it. Okay, whether it is negative definite or positive definite. Okay, so if it is negative definite, then it is local maxima, and if it is positive definite, then it is local minima. Okay, these points are local minima, and I want to find the also I need to find the f of x1 x2, putting these values and give us a exact value of the z. Okay, now I just delete it. Okay, I took a break actually, so I copy it, control C, and I put it over here. Now I want to run the definite test. Okay, run definiteness test. Okay, and for that actually I have this matrix, so I select it, I go to compute. Okay, then I go to matrices. Okay, and in matrices I have the definite test, so I click on it. When I click on it, it says that this is a positive definite. So when the Hessian matrix is positive definite, then we say that this is local minima. Okay, and we also want to find the f of 5 and 2. So for that, f of, go to the mathematics. Okay, now I want to find f of 5 comma 0. Okay, now when I want to find this, so f of 5 0, I would say evaluate it, and it says that it is minus 25. Okay, this is minus 25. So let's see that if I have calculated the same thing actually. So x1 square is actually 25. Okay, plus 5 into 0 square is equal to 0, minus 10 into 5, which is equal to minus 50. So 25 minus 50 is equal to minus 25. Okay, so it is calculated exactly accurate. Okay, so f of 50 is equal to minus 25, and this is the minimum z value that we can achieve over here. So this is how you do the you find the local minima or maxima for two variables quadratic function, okay, using the scientific workplace. Thank you. Okay, so in this problem 3, we will be doing the three variables no constraint problem on the software, which is the scientific workplace SWP. Okay, so let me define the variables over here. So the function that we are doing over here as an example is 4x1 square, okay, plus 7x2 square plus 3x3 square minus 5x1 x2 minus 9x3 minus 6 x1 x3. Okay, so now this is the function that we are doing over here. Okay, and we have three variables x1, x2 and x3. So this problem will be solved using the Hessian matrix, and for the stationary points, actually for the stationary points, okay, we have x asterisk is equal to x1, x2 and x3, and that are found using the partial differential with respect to x1, and we put it equal to 0, and partial differential with respect to x2 and put it equal to 0, and partial differential with respect to x3 and put it to 0. This will give us the stationary points, and then it will give you, when give the stationary points, we want to find if those stationary points are maxima or minima. Okay, then when we do this using the principal minor test. Okay, and for the principal minor we find the Hessian matrix, okay, which is equal to the partial differential of x with the f with respect to x1, okay, and the diagonal elements, actually this will be 3 cross 3 because we have three variables, n is equal to 3, so it is n cross n, which is equal to 3 cross 3 matrix. Okay, and the diagonal elements, actually this it will be the second order derivatives with respect to x1, x2 and second order derivative with respect to x3, and here the first order derivative will be with respect to x2 and the second order derivative will be with respect to x1, and here it will be the first order derivative will be with respect to x3 and second order with respect to x1, and similarly it will be the first order derivative will be with respect to x1 and the second order derivative will be x2. Here the first order derivative will be with respect to x1 and the second will be with respect to x3 and so on. Okay, we will do this, and then after that we will find that whether it is a positive definite, a negative definite, okay, and that will give us whether it is a maxima or minima. So now doing the same problem on the SWP. So let's see. Okay, so here we have the input blank screen, okay, and we will try to define the function and all that and try to solve it using this software. Okay, so first of all, trying the, I would say defining the function, okay, and we'll move to the definition. Okay, for definition we go to the mathematical part of it. So defining the problem into the mathematical part, we say that f of x1, for 1 we say control L, and it will go to the subscript, okay, x1, and press the space bar, then comma, and x control L 2, press space bar, comma, then x control L 3, space bar, and bracket close. Okay, now it is equal to 4x1 square. So 4x, we can actually either write it or we can copy it from here, and then we will put the signs of plus, minus, and whatever the function is. We can do both. Okay, so let's I will write the first one, and then after that we can copy it. Okay, so for the first one, 4x1 square, I will go to the control L, I would say 1, then I would press the space bar, so it will come to the normal writing. Okay, and then I would say control H, and I would say it is square. Okay, and I would put the space bar and it will come to the normal writing. I would say, then because we have 4x1 square plus 7x2 square, so x2 and x3 I will make the copy, control C. Okay, and I will put it over here. Okay, and it is control V. Okay, for x2 we have 7x2 square, so I will write 7x2, and I would say okay, plus for x3 the coefficient is 3, so 3x3, and I would say control H and square over here, so put the space bar, and then we have 5 minus 5 x1 x2, so minus 5 into x1 x2, so we will copy from here. Okay, make the control C and put it over here, control V. Okay, we will remove the comma from there, so we have like 5x1 x2, okay, minus 9x3, so minus 9x, control L and 3 space bar. Okay, and minus 6x1 x3, so we have minus 6 x1 x3, so for x1 we have control L 1, then x, then control L 3 space bar. Okay, now the function is complete. Okay, now the function is actually complete. Okay, we have now the complete function. Now that the function is complete, we will press the enter button. Okay, but before that actually I will select the whole function and I will press control plus is equal to sign, so it will define it, make the definition. Now to see whether it is defined or not, I will go to the compute, go to the definitions, and I will click on the show definitions. Now it has all the variables defined, so I will close it and I will come to this next line. So in the next line we actually want to find the partial differential for the stationary points, so I can say over here that we want to find the stationary points. Okay, okay, so for the stationary points over here, what I will do is I will find the partial differentials. For the partial differentials, I would say I would come to this fractions, I will pick this. Okay, in the first part I would put this partial differential sign, okay, and multiply it with this function because we want to find the partial differential of this function. Okay, now I have put this and we want this differential with respect to x1, so in the lower part, the denominator, I would say I would pick this one and I will write x and 1, but 1 will be in the subscript, so this is 1. Okay, now I also want to find this partial differential of the function with respect to x2, okay, and also with respect to x3. Okay, so for x2 actually I will delete this x1, okay, and I will put x2 over here. Okay, and for the x3 I will delete this x1 I will put x3 over here. Okay, now we have all three partial derivatives with respect to x1, x2 and x3 ready. Okay, now when we have all the things ready, we want to calculate it. Okay, so the for the calculations, actually I will zoom it out. Okay, so for the calculations, zoom it in a bit. Okay, for the calculations, actually what we do is we select this, okay, and press Ctrl E. Okay, E for evaluate. Okay, so it will make the differentials of it. Similarly, for this I will select this and make Ctrl E. Okay, and also for the third one. Okay, so it will give me the first order differential values for the function with respect to x1, x2 and x3. Now that we have got all these threes, actually what we do is we redefine these as a series of equations. To define these as a series of equations, what we do is we Control D. Okay, we can just select it and put it equal to 0. Okay, and when we press enter, it will give us a space for another one, and when we press enter, it will give us a space for another one. So for the second one, actually we copy it from here. Okay, make Control C and we paste it over here and make it equal to 0. For the third one, what we do is we actually make the Control C and paste it over here and equate it to 0. Okay, now we can also make the calculations again. Okay, here because we lost it, I actually converted it to this. The other one I copied it, but this one I actually converted it. Okay, so I would say Control E and it will give us the exact same thing. Okay, now we have a series of equations. Okay, and I want to solve these three equations for x1, x2 and x3. So selecting all these, okay, or I can say here I will enter it and I will solving equations and press enter. So for that, actually I have to copy this thing, Control C and press it over here. So now we have a series of equations. Now when we have series of equations, I just select it and I will go to compute and solve it for the exact value of x1, x2 and x3. So it will give us the exact value of x1, x2 and x3. Now we want to find whether these values x1, x2, x3, these stationary points, actually these are maxima or minima. For that, I would say here maxima or minima. Okay, this is the part of the problem that we want to do, actually. Okay, to do that, actually what we do is we find the Hessian matrix, and then based on that we find it like whether it is a positive definite or negative definite, and then we conclude that whether it is maxima or minima. Okay, so for that I will first define the Hessian matrix. So I can say that H E S S I A N M A T R I C. Okay, Hessian matrix. Okay, so let's see that if we can calculate the Hessian matrix from here. So matrices vector calculus, and I can say that for Hessian No, we cannot do it over here. Okay, now let's see if we can do it from here. Compute calculus, vector calculus and Hessian matrix. No, we cannot do it from there also. So let me define a matrix. This is the for matrix. Okay, this is the matrix, and we have an order of 3 variables, so 3 cross 3, 3 cross 3, and I will press OK. Okay, now in the first one, let me see if I can do it another way. Okay, I am pausing the video over here and I am trying something. Okay, so the first one is the second order derivative with respect to x1. Okay, and both our derivatives are with respect to x1. So I would say that I would copy it from here, or actually this is x1 actually, so I will copy it from here and paste it over here. Now we have this is the first order derivative, so I will make it second order derivative. So for second we need to put square over here, so I will say control H and we have a square over here. Okay, now on x1 I also need a square, so I will press control H and make it a square. So first we need to define the diagonals, because diagonals are regarding the same variable. Like x1 over here, we will put x2 over here and x3 square over here. Okay, this is for the same variable. These elements are with respect to x1 and x2, okay, x3 and x1 and so on. Okay, so these other variable, these other matrix parts, these include 2 variables, but here on the diagonal it includes only 1 variable. Okay, this is for x1, the second diagonal element, this is for the x2 and this is for the x3. So what I do is I will copy, make control C and I will paste it over here. Okay, and also I will paste it over here. Okay, now we need to find this with respect to x2, not x1. Okay, so I will delete this 2 and I will this 1 and put 2 over here. Similarly here I will delete this 1 and I will put 3 over here. So now we have the second order differentials with respect to x1, x2 and x3. Okay, now here we will have the second order derivative with respect to x2 and first order derivative, first order derivative with respect to x2 and second order derivative with respect to x1. Okay, now I will make the control C and copy it over here. Okay, let's delete it. Okay, I will make this thing copy and paste it over here. Okay, now the first order derivative is with respect to x2, so I will multiply dx2 over here. Okay, x and control L and this is 2. Okay, and here this is second order derivative, so I need a power 2 over here, so I will. Okay, now copying this thing and the next one also. Okay, this is the x3 column, so the first will be regarding x3 and second will be regarding x1. So this 2, I will delete this 2 and put it as put it as 3 here. This 2 will be deleted. Okay, now I will, because here it will be the first one will be with respect to x1 and the second one will be with respect to x2. So I will actually copy this and paste it over here. Okay, now here actually I will replace this with 1 and the first one, this one, I will replace it with respect to x2. Okay, now I will make the copy and paste it over here, but here the first one will be with respect to x3, So I will remove this 1 and put x3 over here. Okay, now what I need to do is I need to do this and this one. So this one will be with respect to x3 and the first will be with respect to x1. So I need to copy this. Okay, the first one is x1, that is done, but here the second one is with respect to x3, so I need to change that. Okay, here also the second one will be with respect to x3, but the first one will be with respect to x2. So I will remove this 1 and put 2 over here. Okay, now our Hessian matrix is complete. I just need to calculate it. Okay, so I will make control E and it will give us a Hessian matrix. Okay, now I need this Hessian matrix to be either positive definite or negative definite. Okay, so I need to check the definiteness of it. So I will copy. Okay, I will say control C and I will copy it over here. Okay, and I will select it and go to compute. Okay, I will go to compute. I will go to the matrices, and from matrices I must go to the definiteness test. Okay, so it is positive definite. So when a matrix is positive definite, it means that it is minima, I guess. Yeah, so we can say that it is minima. Now we need to find the function, the functional value for the x1, x2 and x3. So I must actually write in the mathematical form, and I write f of so let's see that what were the values of x1, x2 and x3. Okay, so x1 was 42, x2 is 15 and 87 by 2. Okay, so 42, 15, 87 by 2. 42, 15, 87 divided by 2, and I would put the bracket close, and then I would go for the control. I will solve it for I can even compute it. Yeah, minus 783 by 4. This is the minimum value which we can achieve from this function, and the points, the stationary points, are the local minima. Okay, so this is how you deal with the 3 variable problems in the scientific workplace. Thank you. Okay, so in this video we will be doing the problem 4, and it will be 2 variables problem with the one constraint, equality constraint actually. Now we will be doing the problems with equality constraint, and equality constraint is only 1 and 2 variables. So n is equal to 2 and m is equal to 1 for this problem. Okay, and to use it in the SWP we need to find the basics of the problem. So the basics of the problem starts with defining the function. Okay, so first of all we have like optimize z is equal to 6x1 square plus 5x2 square. This is the main function, and it is subject to the h of x, which is the constraint, and the constraint says that x1 plus 5x2 x1 plus 5x2 is equal to 7. So this is the constraint and this is the main function. Okay, now we introduce the Lagrange multiplier lambda to actually convert these two into a single line. Okay, so we convert it into the software, and also we need to find the stationary points. Okay, so the stationary points x steric will be x1, x2 and lambda. Okay, so to find x1, x2 we need to find the partial derivatives. of L, which is the Lagrange function, okay, and equated to 0 with respect to x2 and equated to 0 and with respect to lambda and equated to 0. It will give us the stationary points, okay, and when we find the stationary points, actually we need to see if it is minima or maxima. To find whether it is minima or maxima, we make the Hessian border matrix, okay, which is m plus n cross m plus n. So it will be 3 cross 3 matrix. Here it will be 0. Here it will be the partial derivative of h with respect to x1 and partial derivative of h with respect to x2. Here it will also be the partial derivative of h with respect to x1 and partial derivative of h with respect to x2. And here it will be the partial derivative of f with respect to x1 and the double derivative of h with respect to x1. Okay, here it will be the double derivative of the f with respect to x2 and the second order derivative with respect to x1 minus lambda into the first order derivative with respect to x2 and second order derivative with respect to x1, and this will be for h. Here it will be the first order derivative of f with respect to x1 and second order with respect to x2 minus lambda into the first order derivative with respect to x1 and second order with respect to x2. And here, as it is the diagonal element, so we will have both order derivative with respect to x2 for f and h. So minus lambda into d square of h by dx2 square. Okay, so we need to find this, and after that we will find if it is positive definite, negative definite, and based upon this we will say that if it is maxima or minima. So let's do it in SWP. Okay, so we have now the blank screen for putting the function and all that. So first of all we will introduce the function. So the function is optimize z is equal to 6x1 square plus 5x2 square. So we have two variables over here. So let's define the function. Okay, for that we go to the part of it. Okay, m, we select m over here. Okay, now we are ready to define the mathematical function. So we have f of x1 and x2. Okay, so x1 will be control L and it will be 1. Okay, press space bar and it will return to the okay, so let's define the other function also. So I will say comma and press x2. So x2 we have control L and I will put 2 over here. Put space bar, press space bar actually, and make it the bracket close and equate it to 6x1 square plus 5x2 square. So 6x for 1 I would say control L 1 and put the space bar and I would say control H, and here I would say 6x1 square is written plus. Now I need to write 5x2, so 5x control L, this is 2 space bar control H, and I will write 2 over here. Okay, and again pressing the space bar. So here, now this function is actually ready. Now we have another function, okay, which is the constraint function. Okay, so the constraint can be written as g of x or h of x. Okay, so let me write it as h of x over here. So I'm defining, so first write it in mathematical form because it is an algebraic formula, or algebraic form. So we have h of this x1 and x2. I copy it from here, control C, and I paste it over here, control V. Okay, and it is equal to x1 plus 5x2. So I copy it over here, control C, and I paste it over here. Now we have the space bar will be removed. The space bar, I'm saying about the comma will be removed. Okay, and we have that x1 plus 5x2. Okay, x1 plus 5x2 is equal to 7. So I will write it as minus 7. Okay, is equal to 0. I will write it into this form. Okay, this is the form of it that we need over here. Okay, this is the function being introduced. Okay, I will press enter and will come to the next line of the definition, but we need to define it. Okay, we need to define it actually. Okay, and to define it, let me adjust zoom on over it actually, because it is auto focusing and it is making it a little bit blur and all that. And at 0.5x it is better. Okay, now what I need to do is I need to introduce the lambda, and also I need to write it into the Lagrangian form L. Okay, so now I can say that let's introduce it, make the definition. Okay, go to compute, select that, go to compute, and compute, go to definition and say new definition. Okay, now the first function is defined. Now I need to define the second function also, which is h of x1 x2. Okay, which is the constraint function, and I also say that it is. Now let's see whether they are introduced or not. I will say show definitions, and it is showing both of the definitions. Okay, now I need to focus on my third line. The third line will be to introduce the Lagrangian function and lambda. So I would say that capital L. Okay, let's talk it in mathematics. So I would press this T button. Okay, and it will comes out into mathematical form. So I would say L, capital L, is equal to f of x1 x2. I will control C, control V, minus lambda into the constraint. Okay, lambda into the constraint. Okay, I would. Now this is the Lagrangian function being introduced. You can also write it as I can also write it as L is equal to f of x1 x2 minus lambda into h of x1 x2. I can write it as. Okay, let's write it that way. Okay, and then solve the problem. Okay, let me enter lambda of, I will control C and control V. Okay, now I also must define it. Okay, like here I also must actually define it. So let's go to compute definitions and new definition. Okay, now this is also defined. Let us confirm it from the definitions. Okay, show definitions. Now we know that it is already defined. Okay, so press close and press enter to come to the next line. Okay, now we have the Lagrangian function over here. Now what we need to do is we need to find the stationary points, and for stationary points we need to okay, for stationary point what I need to do is I need to make the partial derivative with respect to x1, x2 and lambda. Okay, so for partial derivatives I must go to the fractional part over here. Okay, this is the fraction. Click on this and make the fractions. So partial derivative of L, I need to find the partial derivative of L actually. So I copy it and paste it over here, and I need the partial derivative to be done with respect to x1. Okay, and also I need this partial derivative to be done with respect to x2. So for this I copied that and I will delete this 1 and I will put 2 instead of 1. So now my term actually is ready, and also I need to make the derivative. Okay, make the derivative based on lambda. Okay, the partial derivative with respect to lambda. For that I copy it, okay, paste it into the next line. Okay, and this x2 will be deleted. Okay, x2 is deleted and I introduce lambda over here. Okay, now we have like 3 things that were important. Now I would say to evaluate it. For that I must press Ctrl E to evaluate it. So the partial derivative of L with respect to x1 is 12x1. Okay, and the partial derivative of L with respect to x2, let us calculate it. This is equal to 10x2, and the partial derivative of L with respect to lambda, let me calculate it, Control E, it will give us 0. Okay, now we have all the 3 partial derivatives. Okay, this is a kind of system of equation. Now we must put actually these, I need to put all these 3 equal to 0 to find the value of x1, x2 and lambda. Okay, but the third one is not giving me actually the exact value. Let me do it again. Okay, so I did only one thing extra, that is I introduced this L as this thing. Okay, we can also write this as an f of x minus lambda into x1 plus 5x2 minus 7. Okay, so it will give us the values of this, like just I found it. Now we have three values that we found. Okay, so for the three values, actually what I will do is I need to equate it to 0. So I will make the control C and equate it to 0, and let's suppose it show it as pressing control D, selecting it and pressing control D, it will introduce it like this into the for system of equations. Now enter it, and I will say 10x2, control C and put it over here, control V is equal to 0 and press enter. So it will make a third one. So in the third one I need 7 minus 5x1 5x2 minus x1, control C, control V and put it equal to 0. I need to solve now this system of equations. To solve this, I need to go to select it and go to compute and solve for the exact values. Okay, now when I solve it, sorry, solution is 0. Okay, so x1 is equal to 0, x2 is also is equal to 0. Okay, so it is giving me a solution of 0, but I need it as x1 is equal to 0 and x2 is equal to 0. So let me do it again. Okay, one thing that we did wrong was that the new introduction of the lambda is this one. Sorry, L, the Lagrangian function is L is equal to 6x1 square plus 5x2 square minus lambda into x1 plus 5x2 minus 7. Okay, this is the Lagrangian function actually. Okay, so we need to make the derivative with respect to of L, this L with respect to, so I will delete this L. Okay, and I will copy this. Okay, I will copy this, control C, and I will put it over here. Okay, similarly I will delete this L and copy that L over here, and let's see what happens now. Go to compute and evaluate. Now we get a value of 12x1 minus lambda. Okay, similarly here let's compute it. We get 10x2 minus 5 lambda. Okay, and here this is already done, that is correct. So now we need to solve these three equations simultaneously. Okay, now introducing the first equation, control C, control V and control D. Oh, what happened actually? Okay, control C and let's put it over here and equal to 0 and press enter, and here we say that control C, control V equal it to 0 and control C and control V and equal it to 0. Okay, now we have actually these three set of equations. So go to tools, compute, select it and go to compute and solve it for the exact values of lambda, x1 and x2. So these are the values that we get for lambda, x1 and x2. So now we have the stationary points actually. So after that we need to know whether the stationary points are maximum or minimum. For that we need to make a Hessian border matrix. Okay, so for that I would say Hessian bordered matrix. Okay, so for that I need to introduce a matrix of m plus n cross m plus n. So m plus n over here is m is equal to 1 constraint and 2 variables, n is equal to 2, so it is 3 cross 3 matrix. Okay, so I need to introduce a matrix from here. Okay, so I click on this and this is already 3 cross 3, so I press OK, and this is the Hessian border matrix. So the first thing is that it is first is 0. Okay, the other is the partial differential of h with respect to x1. Okay, so this is the partial differential and this is of h actually. Okay, partial differential of this thing actually, and it is with respect to x1. So let's okay, and the third element, this one, we make control V over here, and instead of x1 actually we put x2. Okay, but for x2 I would say control L and put 2 over here. Okay, and we know that this thing is already, this is equal to this, and this third element in the row is also the third element in the column 1. So we write it over here. Now here is the catch. Here is the double order derivative, 2 order derivative with respect to x1 of f and h also. Okay, so we have to write actually here is the partial derivative but squared one. Okay, so I would say h and this is squared. Okay, so partial derivative of f of x1 x2. Okay, this thing, let's control x, cut it, and control V, put it of. Now we know that this is with respect to, this is diagonal element, so diagonal element is with respect to the same one. Okay, this is x1, this is also x1, so it will be x1 square. Okay, actually, so partial derivative with respect to x1 square, so x1 copying from here. Okay, put it over here, x1 and control H square. Okay, now we have minus lambda into the partial derivative of h with respect to x1 square, so making the control C and actually deleting this thing and control V, and instead of f we need to do the h function, which is the constraint function. Okay, this thing is now complete. So this is also diagonal element, so we will copy it, control C, and make a paste over here, and here for x1 we will delete the 1 and we will write 2 over here, and here also we will delete 1 and write 2 over here. So this one is ready now, and so far for this the first order derivative it will be with respect to x2 and the second order derivative will be with respect to x1. So we make the control C and control V over here. The numerator will remain same, but the denominator actually here we will remove the square, and here we will write x, okay, and here we will also write the same thing. We can copy from here, Control C, and paste it over here. Okay, now copying this and pasting it over here. Now here this 2, it will be removed and we will write 1 over here, and this 1 will be removed and we will write 2 over here. The first order derivative will be with respect to x1 and the second order derivative will be with respect to x2, and here doing the same, we will write 1 over here and this 1 will be removed and we will write 2 over here. Now the matrix is complete. So we select the whole matrix actually and press Ctrl E. So it will give us a Hessian bordered matrix. Okay, now once we have the Hessian border matrix, we press enter over here. Okay, and we copy this matrix, Ctrl C, and paste it, Ctrl V over here. Now we have the Hessian border matrix right here. Okay, now we want to know if this is a positive definite, negative definite, or it is a saddle point. Okay, so for that I need to go to compute the matrices and the definites test. Okay, so this is indefinite. Okay, so this is the saddle point over here. Also we need to find the determinant of this matrix. Okay, because in the Hessian border matrix we start from 2m plus 1 size. So 2m plus 1 is 2 into 1 is 2 plus 1 is 3. So it is, we start from 3 cross 3. So 3 cross 3 is the same matrix. We go to compute and we go to the matrices and we go to the determinant. If the determinant is negative, it is minima. If determinant is positive, it is maxima. So we click on it and the determinant is minus 310. Okay, so it is minima. Okay, so this is how you find the Hessian border matrix and all that and find the minima or maxima. Now I will like to find the f of x1, x2 and this lambda actually. So for that I must go to the mathematical part, write f of the x1 value is 42 by 11. So writing 42 by 11 separated by comma, x1 is 7 by 31. So I will write 7 by 31 comma x2 is 42 by 31. So comma, and lambda is 84 by 31. But in function we don't have any lambda over here, so I will close the bracket and I will select it and go to compute. You can also evaluate over here. Okay, and also you can solve it. So the z value is 294 by 31, which and I solve it for the numeric. Let's solve it for numeric actually to get us some value like 0 point something or 5.9 or something like that, for numeric. I will solve it for the numeric. Okay, it is not solving it, so I can just evaluate it and find the value. And 294 by 31, it will be equal to something 9.8 or something. Okay, so this is the exact value of z. This is the minimum value that we can achieve.